Hello, everyone. Welcome to the Solutions Architect Associate Training Program, the bootcamp that we have prepared for you. So this is the week 2 of our bootcamp. And today's session 3, we are going to cover compute services on AWS. And I'll be doing the session today. So before we get started, can you quickly let me know if you're actually able to hear me? If you could just quickly put it on the chat if you're actually able to hear me or not. All right. I think just had Swapnil saying good afternoon. I hope I'm audible. Okay, great. All right, folks. Like I said, this is the Certified Solutions Architect Associate Level Bootcamp. So in our previous sessions, we had introduction to cloud and AWS, and we also had kind of a deep dive into S3. In this week's session, we have 2 sessions, today and tomorrow at the same time. And today's session is about compute services on AWS, which means it includes services like EC2 instances, your ELBs, your EBS volumes, etc. So we'll look at some of those services. In tomorrow's session, I believe that's scheduled to be for serverless. So we'll have all of the serverless services like Lambda, API Gateway, and all of the other serverless services. So I hope you are going to attend that session as well. Okay, so without further ado, let's get started with today's session. Let me just switch my screens. All right, so let's get started with EC2 instances itself, which is basically the core component of the compute services on AWS. Now, what we'll do is we'll first of all look at a quick introduction to EC2. We'll look at all of the different EC2 families that are there. We'll look at some of the billing models that are available, something called tenancy models, which is kind of important to know what kind of EC2 instance you need. And then hopefully, if we have some time, we will do some labs as well. So this is just the EC2 part. So like this, we'll also cover the EBS and ELB and all of that. And we have about 2 hours, so hopefully we can get through everything. So before we understand EC2, let's try to understand what virtual servers are. So, we have the physical servers, right? Like your laptop, your desktop, etc. These are actually physical computers. Now, on the cloud, you do have these physical computers, but then they're not like when you say an EC2, they're actually not a physical server. They're basically a virtual server. Now, what is a virtual server? The idea here is that you're taking a physical server and then you're running some software on it in order to create multiple servers within that server, right? This is to ensure that you're trying to divide the resources of the server so that it's better utilized. Also, the fact that you can kind of run different services on different servers instead of just being stuck with one server, right? So if you look at the screen over here, you see that there is the physical hardware that's present. Let me just bring up the pen here. You have your physical hardware, which is your actual physical server, which includes your motherboard, your CPU, your RAM, and all of that, right? And on top of that, you will have an operating system that you will use, which is, could be Windows, could be Linux, anything that you prefer to use. Then you have a service or an application called an hypervisor. Now, this is what actually allows you to create the virtual servers on top of your physical server, right? So some of the virtual servers that you might have, some of the hypervisors you might have heard of are something like VMware. Sorry, my pen is a little bit slippery today. So you have VMware. And then you have other services like Hyper-V, Microsoft Hyper-V. Then you have several Linux-based virtual hypervisors like Zen, KVM, etc. Right? The job of this software is to kind of create individual virtual servers within your physical server. Now, these virtual servers are basically these guest servers. So guest 1, guest 2, and depending on how many you want to create. So as an example, let's assume that this particular physical server has about 8 CPUs. okay, and it has about, let's say, 32 GB of RAM. So what you want to do is you want to kind of divide that between these instances, in between these virtual servers. So you might give one of these virtual servers like 2 CPUs and like 4 gigs of RAM, right? And then you might give another instance, maybe like 1 CPU and 2 GB of RAM, right? And then you might want another virtual server with, again, maybe another four CPUs and maybe another 8 GB of RAM, right? The idea here is that you're dividing this physical server into multiple smaller virtual servers within which you can individually run applications within each of them, right? And because they're all different servers, it doesn't matter, kind of, if you have, you can actually put Windows on one, you can put Linux on another one, and other operating systems as well, right? Or you can have two Linux, two Windows, etc., or multiple Linux and Windows. The idea here is that you're trying to get you're trying to ensure that you have different isolation between these servers, in the sense that what you're doing on one server doesn't really affect the other server, right? So any questions on virtual servers? Let me just quickly check. Right, don't see any questions yet. Great. So let's talk about how this translates to something like an EC2 instance. So all of these virtual servers that you see are basically what your EC2 instances are, right? So all of these virtual servers are your EC2 instances. It's basically Amazon or AWS creating virtual servers for you, which then you are essentially using as EC2 instances. Of course, you can select maybe a Windows EC2 instance or a Linux EC2 instance. The hypervisor ensures that there is no kind of interruption between these instances. So this might be your instance, this might be someone else's instance, right? We will talk about how that separation takes place. But essentially, you get to run your own server, which is a virtualized server, not a physical server. Okay, so there are different types of EC2s that you can select from. We'll be giving these slides to you so you can go through all of this individually if you want to kind of look at all of the points. But just to give you a brief idea, you have servers that are ranging in sizes from something like nano to 32x large. And I'll talk about how you kind of make sense of these sizes. You have Linux, Windows, and recently they introduced Mac as well. There is also x86 architecture as well as ARM. ARM is basically the same processors as what you have on your phone, right? So all of the Snapdragons, etc., are based on ARM. So you can, in fact, select an ARM-based processor on AWS. The one that they have under ARM, it's called Graviton. So it's not like your Snapdragon, it's called Graviton. So if you need to run ARM-based applications, you do have that option as well, other than just running Intel or AMD processors. 400 different type of instances. We'll talk about how you differentiate them. And of course, you can scale up and down based on your requirements. And you always pay for what you use. And also, AWS has their own custom hypervisor known as the Nitro hypervisor. So we'll talk about what Nitro is a little bit later on. Okay, the different types of instance families. So there, like I said, over 400 different type of instances. So you have a lot of instances to choose from. But the idea here is that you have different instances that are good at one and maybe not really good at the other thing. For example, compute intensive instances, they have the best CPUs, right? So even if there are two servers that are compute intensive and memory intensive, if you take, for example, the R5 and the C5, there might be servers where both of them have only 2 CPUs, right? Or 4 CPUs, both of them have 2 CPUs or 4 CPUs. But the CPUs on the compute intensive will be more powerful than the one that you have on the memory intensive, right? So that's the idea here. The compute intensive has better CPU processors. And when you talk about the memory intensive, they obviously have higher memory. So for example, if you take a C5, you might get a C5 instance with 2 CPUs and maybe 4 GB of RAM. But the same one on R5, you might get an instance with 2 CPUs and 8 GB of RAM, right? So you basically get more GB for kind of the same money, right? But remember, your processor is still not as good as what you get on the compute intensive. The reason this is there is because depending on your applications that you're running on the cloud, you might have different requirements, right? You might need a server which has a lot of memory, and the processing is important, but it might not be that important, right? That's where you go for something like a memory intensive. But then if you're running heavy compute based applications where memory is not really much of a problem, your application can still run with low memory, then you definitely want to go with something like compute intensive. And obviously with storage optimized, you get a lot of additional storage which you kind of don't have to pay for. It kind of comes with the instance, so you don't have to kind of pay for the additional storage. So if you have applications that require a lot of storage space, you might want to go with the storage optimized. You have other general purpose, which is kind of a balance between CPU and memory and storage, etc. So you kind of get the best of all of the worlds. So if you're not sure what type of instance you need, you can probably select one from the general purpose family. And there is something called accelerated computing, which is for things like AI, ML, and graphics processing, etc. Right? Within each of these families, of course, you have these different types of instances. The one thing I just want you to keep in mind right now is if you see something like a C5 and then you later on see something like a C6, it's just that the C5 is an older generation compared to like the C6, which is a newer generation. But then we'll talk about what each of these mean, like GN or G and A, etc. Right? Quickly, if you have any questions, please do post it in the chat. Yes, like I mentioned, the slides will be shared, so no worries about that. Okay. All right. There are some additional features that have come to EC2 instance over the last few years. There is the option of bare metal. So we talked about virtual servers, right? But you do get the option to also buy a physical server on AWS, like rent out a physical server on AWS, which is known as the bare metal servers, right? These are not your regular EC2 instance. They are the physical server which you can start on EC2, and then you can run your own operating system and your own hypervisor and all of that. It's just that AWS is completely giving you the hardware. Then you have something like elastic GPUs. This is used, for example, in accelerated computing instances. Sorry. So in accelerated computing instances, you have instances like the G4, which come with graphics cards, right? But the thing is that these systems are quite expensive. So there might be a scenario where you don't need a lot of graphics, but you need some graphics for your application to run. This is where you kind of use the option of elastic GPUs. This will allow you to, for example, take a C5 instance, which does not have a graphics card by default, and then you can basically connect your elastic graphics card or your elastic GPU onto this C5 instance. So you might only need like a 1 GB graphics card, right? So you can go into elastic GPU and assign this particular instance like a 1 GB graphics, so that you don't have to pay too much for a system that actually comes with graphics by default. So that's what elastic GPUs are. Then you of course have VMware on AWS. This came as an association between, partnership between VMware and AWS. This is basically the option where you get to host your existing VMware solutions directly on AWS. This is still a managed service, so you don't get full control over this environment, but you still can kind of run VMware on AWS. So we saw all of these instance families, right? So let me just kind of describe what each of how do you look at an instance name and then kind of figure out what that instance is actually. So the instance family comes from the first letter, right? So if you look at this instance families, under compute intensive, you have all of the C series. Under the memory intensive, you have X, you have Z, R. You have these ones. And general purpose, you have quite a few. That is A, M, and T, right? And for storage, you have I and D and H. So this actually describes the instance family. And the number after that basically describes what generation it is, right? So like I mentioned before, if you see an R4 and an R5, This basically means that an R4 is an earlier generation compared to something like an R5. R5 is just a newer generation. Okay, that's just the difference. And then the additional capabilities. So after the number, if you see something like a D or an A or something like that, it just means that there's some additional capability to that instance. For example, if this says A as an alpha, it means that the processor that this instance has is AMD, right? For Intel, there is no specification. If it doesn't say anything, it basically means it's Intel. And if you obviously have G, it means that it's a Graviton processor, which is AWS's ARM processors. So all of this, like the C6Gs and C6GN, etc., these are the Graviton processors, right? And then N basically stands for networking capability. So you get extremely high network bandwidth. For example, even 10 gigabits per second or 25 gigabits per second. I believe they recently released an instance which I believe goes up to 1 terabyte per second, which is insane. But yeah, so that's the additional capabilities that you can refer to when you look at an instance. A D basically stands for additional disk capacity. So it kind of comes with a disk, which we will discuss later on. And anything after that, basically after the dot, basically describes the size of the instance. So you might have like small, like it's just like your clothing size, like small, large, X large, 2X large, 3X large. So an X large instance is basically larger than a large instance or larger than a medium instance, right? So that's basically what that is. So this is a chart you can look at to kind of see how you plot the different types of instances. So if you see the C5.large, basically comes with about 2 CPUs and 4 gigs of RAM. But at the same time, in an M5.large, it only comes with 2 CPUs, but it has about 8 gigs of RAM, right? So you see they're similar in the sense that the naming convention looks very similar. This is from the compute intensive family, and this is from the memory intensive family. Or I believe this is from the, this is from the general purpose family, not the memory intensive. The memory intensive is the R series. So you get lower CPUs, but if you look at the memory intensive ones, which is the R4s, you have 2 CPUs, but it almost comes with about 15 and a quarter gigabyte of RAM, right? So you get to choose what type of instance you need for your particular requirement. Okay, no questions so far. Any questions? Please do put it in the chat, guys. All right, don't see any questions yet. All right, there are 3 types of ways you actually get billed for an EC2 instance: the on-demand model, the reserved instance model, and basically the spot instance model. So on-demand model basically means you pay for an instance as long as you're running it. So for example, if you started an instance at 10:15 p.m., and then if you shut down that instance at 11:14 p.m., you're essentially paying for an hour of usage, right? Now, all of the usage is coming down to per second billing. So with Linux and Windows used to be per hour before, but then everything is now per second. So you're billed per second. So if you use it for like 10:15 to, let's say, 10, 16 and 30 seconds, you're basically billed for about 90 seconds of usage, right? So it's basically you start it, stop it, and that's it. But sometimes what happens is when there is not enough capacity with AWS, which actually I don't think has happened till today, but it's certainly a possibility. Like if everyone starts EC2 instances on AWS at the same time, it's possible that you will kind of run out of EC2s to start, right? So in that case, sometimes you might not find an EC2 in the on-demand instance. You might not be able to start it on demand. So in that sense is where you actually go for the reserved instances. But there are also other reasons why you would go for reserved, because the reserved instance is not a type of instance. Remember, we are talking about billing models here, so we are not talking about instance type. This is a contract which you're buying for either a 1-year period or a 3-year period, right? So you're basically telling AWS, I will pay you for 1 year, or I will pay you for 3 years So give me the same instance at a lower price, right? So the same instance, for example, an m5.x large on an on-demand instance and an m5.x large on a reserved instance model, the pricing will be completely different. This pricing might be even up to 70% lesser than what you might pay for an m5.x large, right? They're able to give you this low pricing because you're kind of guaranteeing to pay for a certain period of time, right? So remember, if you buy a reserved instance contract, you are going to pay for that regardless of whether you're actually running this instance or not, right? So it's like you already paid for the contract. That contract allows you to run an instance at a lower price, but then if you don't run the instance, it's nobody's fault except yours, because you paid for it and you're not using it, right? So the idea here is that you go for a reserved instance contract if you know for a fact that you need certain number of systems for the entire year that you kind of need to use, so you can get a lower price for that. And the third one is a spot instance model. This is kind of like a marketplace model where you're bidding for a certain price, right? So just like the stock market, even the spot instance marketplace is basically like a stock market where the pricing of the instances vary during different times of the day. So what you are essentially saying is, for example, if you go for a C5.x large, you're basically telling AWS, like you will put in a bid into the spot instance system, right? So you will say that I'm willing to pay $0.15 per hour for, let's assume, a C5.x large, right? This might be obviously lesser than the pricing of the on-demand instance. Obviously, you don't want to bid the same price as on-demand, because what's the point then? So you're bidding for a much lower price. So as long as the market price is below your bid, for example, if the market price currently is at 0.12 or 0.14 or something like that, right? You will get that instance at the market price, right? The only problem here is that because this pricing is market dependent, if the price of the market goes above your bid, then you essentially lose that instance. So it's not a permanent instance. It's a temporary instance as long as your pricing, your bid pricing, is lower than, or sorry, is higher than the market price, right? The moment the market price goes higher than your bid, you will lose that instance. I mean, you will get a 2-minute notification. So whatever you're doing on your instance, you need to kind of close it out within 2 minutes and get out of there and save your data. Otherwise, you will end up losing your data if you have anything saved on the EC2, that is. I'll quickly stop here and ask if you have any questions on the billing models. Right, Zaid, the next slide is actually the savings plan. Okay, I think my video is slightly affecting that. Let me just move it to this side. All right. So when you want to choose one of these plans, like on demand, reserved, or spot instance, you are not going to use either one. You are probably going to use a combination of these, right? So as an example, let's say you are using about 200 servers, up and down, maybe 200, maybe 250 or something like that, right? So you know for a fact that your application needs a minimum of, like, let's say 50 servers, right? So you would kind of put those 50 servers under the reserved instance contract, because you know that no matter what happens, no matter how much traffic comes into your environment, you might need 50 EC2 instances. So you will reserve them. Now, on top of that, depending on your demand for your application, maybe during peak hours, that demand goes up to maybe like 90 instances or 100 instances, right? So you would put them in the on-demand model, right? So this way, you're only paying for the kind of usage that you have during the peak hours and the non-peak hours. You're paying exactly what you need. And then obviously, if you need to do some additional batch processing, you can make use of something like the spot instances, right? Where you can quickly run a batch on the spot instances. Because remember, the spot instance model, it's not a permanent one. As long as your bidding is above the market price, you will have that instance. So you can use that for something like a batch job or something like that, where you don't need that instance permanently. So you're always going to use a combination of these, not just one. Now, they recently added some additional cost-saving measures, which is savings plan and capacity reservation. So savings plan is kind of like your reserved instance, right? So it'll give you the same benefits as a reserved instance, in the sense that it will give you a lower pricing for your instances. But the idea here is that you're not having to prepay for a year or 3 years or something like that, right? You're paying for so what you do here is you tell AWS up to how much amount you can pay, right, every month. So you're going to say like, okay, every month I'm willing to pay up to $100, as an example. Maybe if you're using a starting account, but in the production, in the real scenarios, these are going to be like $10,000, $20,000 upwards, right? So up to the amount you commit, you will get a lower pricing, right? So for example, let's say your monthly bill is somewhere around $180. Let's say this is your average monthly bill, right? Now you want to reduce this bill, right? So what you will do is, in the savings plan, you will tell AWS, okay, I'm willing to pay you $100 every month. I'm willing to commit to paying $100 every month, regardless of what happens. So what happens here is that up to the time that the bill reaches $100, right? Up to the time the bill reaches $100, you will keep getting discount on your EC2 instances. So your EC2 instances will be running at a lower price. But when your total bill goes above $100, any amount that is above 100 will be billed at the standard pricing, right? So up to the amount you're going to commit, as long as the bill is within that amount, you will completely get your discount. But any pricing, okay, I think you can't see what is being written there. So if you say that I'm committing to $100, up to the $100, you are going to get a discount. But anything above 100, you're going to pay the regular price, right? Capacity reservation is also the benefit of having reserved instances, but only for a certain period of time. With reserved instance contracts, you have to sign up for like a 1 year or 3 year in order to ensure that your instance is always available whenever you need an instance. But with capacity reservation, you don't have to do that. You don't have to like say that you need it for a 1 year or 3 year period. You can kind of pay for a certain period of time where you think you actually need additional, you need capacity that should be there regardless of what happens. Then you can kind of use a capacity reservation. So you're only paying for the time that you're saying that you actually need the capacity guaranteed, right? This is always to ensure, both this and reserved instance billing model is to ensure that there is always an instance available for you when you want to start it. That's the reason these two models exist. I hope that's clear. Okay, 3 important models here before I go into the part about the actual demonstration of the instance types. Sorry, the labs. So there are sorry about that. Okay, so there are multiple instance tenancy models. One is a shared host instance, the other is a dedicated host instance, and the third one is a dedicated instance. This kind of describes what is the, like, where exactly is your instance running, okay, or what model is your instance running under. So shared host instance basically means, so if we take this as our physical machine, our physical host machine, this is your physical host, and you have your processor, you have your memory, you have your local disk, etc., right? All of that. And then you have the virtualization layer, which is your hypervisor, which creates EC2 instances inside this. So what essentially happens is, if you start an instance over here, right? So this is your c5.x large instance, right? You started it over here. Is this visible? You have a c5.x large instance here. You started that instance on this particular host machine. The thing with a shared host instance is that there are other people who can come and start instances on the same host machine, right? So this might be yours. This c5.x large is someone else's, right? And then maybe another person comes and starts their EC2 on this one. So you might have the scenario where different people are using the same physical host machine, which is why it's called a shared host instance, right? So you use this if you don't have to meet any kind of compliance or regulatory requirements or something like that. You just go start your instance on a shared host model and you use it, right? The other model is your dedicated host model. Dedicated host meaning that this entire host machine is dedicated for your use. So only you can start instances on this particular host machine, right? So there is no one else who's going to be able to start instances on this. And also remember, when you go for a dedicated host, the host machine is assigned to you, which means even if you don't run instances on it, you're still paying for the host machine. So it's kind of dedicated for your use, right? So that's the dedicated host. This is useful if you want to kind of ensure that you meet compliance requirements and regulatory requirements. For example, there might be some regulatory requirement that says that you cannot run your application in a shared environment where there are other people's servers running, right? So in those cases, you definitely want to use this model. There might also be requirements for licensing where the license has to be associated with a particular host machine, right? So the license is kind of associated with the processor on that host machine. So in those cases, you will have to go for a dedicated host model, right? Then the third model is a dedicated instance model, which is basically only you can run instances on the host machine, as long as you at least have one instance running, right? So if you have one instance running on this host machine is dedicated for you, right? But the moment you stop this host machine, which means you're not running, the moment you stop this instance, which means you're not running any more instances on the host machine, this host machine is no longer dedicated to you, right? So the idea here is that this is a model where you get a dedicated host machine when you're running at least one instance, right? So this way, it's kind of the best of the both worlds, where you don't need to pay for the host machine when you're not running any instances. But at the same time, you get a dedicated environment where only your instances are running. Why would someone choose between something like a dedicated host and a dedicated instance? Well, if you go for a dedicated instance model, remember I told you that when you stop all of your instances, you no longer have this host machine assigned to you. This is a problem if you actually have licenses that are linked to the physical processor on the host machine. So for example, certain licenses are actually attached to the processor of that machine. So when you run an application here and then you attach the license to the processor, and then if you lose this host machine and the next time you start, it goes to another host machine, right? If that is the case, then your license is no longer on that host machine. It was on the previous one, right? So this is not useful, compared to a dedicated host model where the host is always dedicated to you and the license assigned is always assigned to that host machine. However, this dedicated instance model can still help you meet compliance requirements and regulatory requirements where whenever you're running your application, it's always running in a dedicated environment, right? So you kind of have to pick and choose. But almost always, unless you're running financial applications or something like that, you're almost always going to have shared host instances that you're going to use. Quickly checking in the chat if you have any questions on shared host instance, dedicated host, and dedicated instances. All right, no questions. All right, the additional options that I just wanted to quickly mention here is AWS's own hypervisor, which is the Nitro hypervisor. Remember, I told you when we were discussing the concept of hypervisors, the first generation of hypervisors actually needed a host operating system to work on top of it or below it. So you needed to install the host operating system on the physical machine, and then you used to run the hypervisor on it. Now, if you think about this, the physical machine actually has some amount of CPU and memory, right? Like 8 GB RAM or whatever. Obviously, when you run an operating system, it is going to use up some of that memory, right? And when you also run a hypervisor on top of that, this is an application that creates these instances, right? So when you run a hypervisor on top of that, even the hypervisor is using up memory and CPU from the physical server, right? So the second generation of hypervisors were able to completely eliminate the host server OS, and the hypervisor used to be installed directly on the physical hardware. So it used to act both as an operating system and the hypervisor. Now, this allowed you to cut down on the resource usage, so which means now more memory and CPU is free that can be assigned to these individual instances, right? Um, but that AWS went one step further is they completely eliminated the concept of a software hypervisor, and now they have a hypervisor that is directly plugging into the physical hardware, like a physical card, like when you connect your network card to maybe a PC or something like that, like graphics cards, etc. Similarly, the hypervisor, Nitro hypervisor, is a card that connects onto the physical hardware, which basically means the hypervisor is running on the card and not on the server. What this allows you to do is save again more memory and CPU. So essentially, right now with Nitro hypervisor, almost all of the CPU and memory that comes with the physical hardware is available for use by the guest operating systems, right? So this is basically the concept of Nitro hypervisor. Because it's on a physical card which is separate from the physical hardware, you can now use the full server for assigning them to the guest operating systems. And then you have AWS Outposts, which was released a couple of years ago. The AWS Outposts is a physical server that AWS uses in their own data centers. This is the actual server that your EC2 instances run on, right? So they will give you this rack, which you can actually put inside your own physical data center. So all of these are servers. Each one of these are servers inside which you can run your EC2 instances. You, of course, get storage along with this, which is your EBS volumes, which we will talk next. It has several additional capabilities that they have been adding, which is services like RDS, etc., which you can run. But the idea here is that you can take this machine and put it in your own data center, which means the EC2s that you're going to run, it's going to be it is inside your data center, right? So you're going to have very low latency. You can run applications that are extremely latency sensitive pretty fast without using a region in AWS that's very far away from your location. Now, obviously, not everyone is going to use this. You probably need a very good use case like a low latency application which you're serving internally. Then you can probably use this, or maybe good in a region that does not have the AWS data centers, right? So you could use that. AWS this year in reInvent actually released two more servers, which is a 1U and a 4U. So if you see this server here, I hope you can see what I'm drawing on the screen. This is basically 1U or 1 unit, right? And basically 4U basically means 4 of these. So before, if you wanted Outposts, you had to kind of buy this entire thing. Like you had to rent out this entire server. But now you can in fact just get that 1U server, right? Which means it's much more affordable. You can actually get just that one physical server to put inside your data center and run your EC2s directly on that. Of course, when you run your EC2s, it's going to be virtual machines. So inside this, you will have virtual servers which act as your EC2 instance. Any questions? All right, I just want to quickly touch on EBS volumes before I go ahead and show you some labs on starting some EC2 instance, because EBS volumes are kind of core to the actual usage of your EC2 instance, right? So we look at all of the different storage solutions on AWS. We'll talk about what EBS is and how the architecture looks. We'll talk about different types of instance storage that is available, EBS. We'll talk about all of the volume types, snapshots, and then definitely we'll go do some labs. Okay, so just give me 1 second. So when you look at the AWS storage options, there are so many options that you have, right? So you have block storage, which acts as your hard disk. You have file storage where you're storing something like documents or files you're sharing with someone else. Then you have object storage, which is basically S3, kind of what we covered last week. Then you have several other solutions which kind of help this. For example, hybrid, which is a solution between storing data in your data center as well as storing data on AWS. So hopefully we'll cover this in the future. Then you have several options as to how you bring data into AWS and take data out of AWS as well. And then you have several options for backup as well. Here we're just going to concentrate on this part, which is Amazon EBS, which is the block storage. Now, one of the reasons it's known as block storage is because you are basically having to assign a certain block of storage for yourself before you even use that. So you kind of have to assign, as an example, like 8 GB of storage, or like 40 GB of storage, or 100 GB of storage. You're having to like pre-assign that block to your EC2, and then it will use that as your EBS volume. Now you still have to pay for the block that you're assigning regardless of how much you're actually storing. So even if you assign an EBS volume that is 100 GB in size, and even if you're only storing maybe 1 GB of data in it, you essentially have to pay for the whole 100 GB disk, because you're pre-assigning yourself that much storage as an EBS volume. Of course, the other reason why it's called a block storage is because when you talk about hard disks, you have this concept of sectors, blocks, etc., that used to come from the old option of using hard disks, right? So that is the EBS part, which we will cover right now. So EBS is basically an off instance block storage. Now, what does it mean by off instance? Let me just quickly go back to our EC2 section. So before I told you, you basically launch your EC2 instances inside your physical machine, right? Now remember, your EBS volume storages are not on the same physical host machine. So for example, if this is your EC2, your EBS is somewhere else on the network, right? Your EBS is somewhere else on the network, and it's basically getting attached to your EC2 instance, right? Sorry, is my camera kind of... Okay, your EBS is somewhere else on the network, and you're basically attaching it to your EC2 instance. All right, so it's not on the particular physical host machine, it is somewhere else on the network. That's why it's called an off instance storage. Now remember, there are disks that are available on the host machine, and we'll talk about how you use them, right? But your EBS volumes are always somewhere else on the network. You get the option of both SSDs and HDDs, and you can take snapshots of your EBS volumes to the S3 system. Snapshots basically means backups. It does support encryption, and there is something called provisioned IOPS, which I will talk about a little bit later on. The idea here is that if you have one EC2 instance, you're basically attaching your EBS to it, right? And you will always have a boot volume, which is basically the EBS volume that contains your operating system, right? So your operating system will be in that EBS volume, and that will be known as your root volume, and you're essentially connecting that volume to your instance. Now, I kind of said before that your EBS kind of refers to a hard disk, right? Because you have the concept of block storage. So your EBS is acting as your hard disk, but it is not a hard disk. Okay, so your EBS is acting as your hard disk, but it is not a hard disk. What that means is, like I said, your EBS is somewhere else on the network. So it's something that is coming from that service. So it's not a physical disk that you're getting. So your EBS volume is not a physical disk. It's a virtual volume that is getting created within the EBS service. So the EBS service might have like hundreds of actual physical volumes inside it. Maybe it has like maybe 100 terabyte of capacity, right? Out of that, you will say, okay, I'm going to assign myself like a 10 GB, which is going to be your EBS volume, which is then going to get connected to your EC2 instance, right? So remember, your EBS volumes are not physical hard drives. I mean, of course, they are running on physical hard drives, but you are not getting a physical hard drive. Now, ideally speaking, if you have one instance and if you have one volume, you're always going to connect that volume to only one instance at a time. Okay, you cannot have one instance connected to, you cannot have one volume connected to two instances at the same time. Unless you're using the newer types of volumes known as EBS multi-attach, which I will talk about in a second, because there are some conditions there. The idea here is that if you want to use an EBS volume, it will always be attached just with one instance. So if you want to connect it to another instance, you have to detach it from this instance, and then you have to connect it to the other instance. All right. Like I said, there is a newer type of volume known as EBS multi-attach, which you can use for connecting to multiple instances at the same time. But then you wouldn't use that as your operating system volume, okay? Because just like how you cannot connect one physical hard drive with your operating system to multiple machines at the same time, similarly, you can't do that here. So there are some conditions if you're using multi-attach. You can, of course, have multiple volumes attached to the same instance, right? So you can have multiple EC2 instances that are connected to you can have multiple EBS volumes that are attached to the same EC2 instance, where one will be your boot volume, which has the operating system, and the other one will be like your data volumes, where you actually store the data, right? Just looking at the EBS architecture, remember I told you that the EBS is not on the physical host machine where your EC2s are running, right? So it's not on the physical host machine, it is somewhere else on the EBS cluster, right? And you are basically creating these volumes on the EBS cluster. So for example, this might be a 100 GB hard drive. This might be like a 10 GB hard drive. When I say hard drive, I'm talking about EBS volumes. So this might be like a 20 gig. This might be like a 5 gig, etc. So you can create multiple volumes within the EBS cluster, and then you're essentially attaching that to your EC2 instance to use as an EBS volume. Now, like I said before, you can have one volume attached to your EC2 instance or multiple volumes attached at the same time, but there will always be one root volume or one boot volume that gets connected. Now, there are storage available within the sorry, I think my cam is kind of affecting. Okay, just made it a little bit smaller. Okay, so there are actually hard disks on the instances, like I mentioned before, right? So it's known as instance store. You get SSDs and HDDs. So the instance store is basically the physical disks that are there present on the physical host machine. Now, if you can see, you can actually get your EC2 instances attached to these instance stores, which means that they don't have to go over the network using the EBS data pipeline. They don't have to go over the network to the EBS cluster. So there is an advantage to using the instance stores, which is obviously that it is going to be faster because you don't have to go over the network onto the EBS cluster. But not only that, because your EBS is going over the network, there are certain limitations on how fast you can transfer data, right? So depending on your instance size, instance type, and the EBS volume, you're always limited in how much data you can transfer, right? You are not always going to get the full potential because depending on how much you have assigned, how much of a size of your volume, as well as your EC2 instance, the data transfer rate is going to be different. But if you look at this, there is no limitation here because obviously it's right there on the physical machine. So you can get the full ability of these hard drives that are there on the instance stores on the physical host machine, right? The only thing here to remember is that your instance stores are known as ephemeral. Okay, so your instance stores that you have within the physical host machines, they're ephemeral storage, which means they're not permanent, they're only temporary. What do you mean by that? Is if you're connecting one of these hard drives and if you're using it, and let's say you stopped your instance. Now, one important thing I need to clarify here is that your instance, there is a difference between a stop and a start and a restart. Okay, so there's always a difference between a stop and a start and a restart. So if you restart, there's nothing much that's happening, but if you stop and start, there's a lot of changes that take place. Just give me 1 second, guys. All right, so if you are using an instance store, okay, and if you stop an instance, everything that was there on that instance stores get wiped clean. Okay, so you're running an instance, you had instance store attached, you stored something there, but then you stopped your instance and you started it back up, or you stopped and you never started it back up. Everything that is saved on the instance store gets wiped clean. So it is a temporary storage, which means you can use it for anything that is temporary, like log processing or a lot of data analytics where you're needing to have fast access to your data, but then you might not need it after a certain amount of time, right? So that's what your instance store is going to be used for. So it is extremely fast, but there's always like a catch here, which is that if you stop and start your instance, you're going to lose the data on your instance stores. There are different types of volumes that are available for your EBS volumes. So for your instance stores, there is only SSD or HDD. Okay, you get to choose between solid state storage as well as your typical hard drives. When you talk about EBS volumes, then under EBS SSDs, you have several types of volumes, and even under EBS HDD, you have two types. In fact, they released another two recently, so about four types of volumes that are there for your EBS HDDs. The reason I'm not showing you all of the latest releases is because of the fact that the latest releases don't come in the exam until maybe another 6 months to 1 year down the line, right? So don't worry if you don't see everything latest here, because this is what will mostly come in the exam. We have a question: what is the difference between stop and restart? So when you stop and start, that EC2 instance is basically getting almost recreated every single time, right? So that's why everything associated with your EC2 instance kind of goes away, and then you have to kind of reattach everything. But if you do a restart, it's only on the software level. So a stop and start is happening on the hardware hypervisor level. The hypervisor is the one that creates the EC2s. So if you do a stop and start, it's happening on the hypervisor level. But if you do a restart, it's happening on the operating system level, just like how you go to Windows and do a restart, right? So it's happening on the operating system level. That's the difference. Okay, just coming back to your EBS volumes. So you have different types of SSDs and different types of HDDs for EBS. Now, I'll be sharing this slide so you can look at all of the performance characteristics of these EBS volumes and your EBS HDDs. But I'll just quickly show you this table, which is a comparison for your EBS volumes. You're primarily going to be using either a GP2 or a GP3 volume. All right. These are your general purpose SSDs under your EBS volumes. GP3 being the latest one, and GP2 being the previous version, right? I mean, you can still use GP2s, but you obviously get a better performance and a better pricing if you kind of use GP3 volumes. Now, the main difference here, if you look at this, is in terms of IOPS. If you look at your SSD volumes have a lot of IOPS compared to your HDD volumes, right? Your HDD volumes has pretty poor IOPS, right? What is IOPS? IOPS is input output operations per second, which basically means how many times within a second can you read and write data, okay? So we are not talking about the speed of transfer of data. Speed of transfer is something different, but we are talking about speed of access, right? How quickly can you access something before you start reading it, right? So you access something in order to read it, or you access the disk in order to write there, right? So how many times within a second can you quickly access your disks is what IOPS basically tells you. So because your SSDs don't have any moving parts in them, you're basically able to access the disk much quicker every second, right? But because your HDDs are a physical, those old magnetic disks which have the rotating disk platter in them, because it takes time for the disk to rotate and you get to the location where you need to get, the number of times you can do that in a second is obviously much lesser. All right. However, if you look at throughput, if you look at the throughput of your SSD, which is your GP2, which is 250 megabyte per second, but if you look at your HDD, it's actually bigger. It's actually better than your SSD. So HDDs are still useful. This is throughput. Throughput defines how much data you can transfer after you access it. So the speed of access is IOPS. Once you access it, how much data can you push through within a second? That's what this defines. So your HDDs are still good at it. So which means large files will get written to your disk much more quicker, with your HDDs. But smaller files will obviously get written much more quicker on your SSDs because it's able to access the disk much faster and write the file pretty quickly, compared to accessing the disk and then writing a very large file which can take time to transfer onto the disk. So in those cases your HDDs are still better, right? So this can be for transferring large amount of media files, for storing large amount of media files, to storage large backups, etc. Your HDDs are pretty good at it. All right, so you will still need to consider HDDs. Just because SSDs happen to be much more faster doesn't mean you completely ignore HDDs when it comes to usage, because if you look at the pricing is much more cheaper compared to your SSDs. So you might get better pricing for storage if you look at HDDs. Any questions here? All right. The difference here is that with provisioned IOPS. So I talked about IOPS, right? Which is input output operations per second. With your GP2s, what you used to get is for every GB of storage that you assign, you used to get 3 IOPS. Okay. So if you, for example, had a 100 GB EBS volume that was a GP2 volume, you essentially only got 300 IOPS. Okay, which is 300 input output operations per second. The problem is when you talk about large websites, let's say there are 1000 people on your website right now, okay, and all of them are browsing something, they're clicking on something, they're doing different activities. So all of these are actually operations that someone is performing. So when you have such low IOPS, your site becomes slow, the read and write gets slow, everything slows down, right? So if you're looking for running large websites or large production workloads, especially databases where you need a lot of read and writes pretty quickly, this will not work out, which is why you need provisioned IOPS, where you're not limited to this IOPS per GB kind of a concept. You can individually assign GB and you can individually assign IOPS, right? So I can, with IO1, I can basically have a hard drive that is maybe only 10 gig in size, but then I can maybe assign 1000 IOPS or 10,000 IOPS, right? So it doesn't limit me between the size of my volumes as well as the number of IOPS that I need. So that's why you have this provisioned IOPS volumes. So just remember that there might be questions in the exam asking, if you have a database that you're running and you need set number of IOPS, what is a disk that would be better? Then obviously it will be the provisioned IOPS compared to your GP2s. This is a quick difference between your SSDs and HDDs. Like I said, I'll be sharing the slide, so you could always have a look at it later. The idea here is that with your SSDs, you're always looking for quick access speed. So small files, fast access is why you will use HDDs. But if you have large files and you need cheaper storage and you need to write lots of data, but the speed doesn't matter that much, that's when you will go for your HDDs. Okay, let's actually switch over to the labs and we will go ahead and start some EC2 instances. All right. Once you log into your consoles, you will have the option of going to the EC2, and this is your EC2 dashboard where you're going to see all of the instances that you have running or not running. So if I go into instances here, I don't have any instances right now, no EC2 instances. Okay, let me just move my cam a little bit. All right. Now, always remember on the top right-hand side, you have the region where you are actually going to be creating the EC2 instances. So always remember to select the right one. Just to let you know, North Virginia has the maximum number of services available. So if you want to use every service available on AWS, you probably want to use the North Virginia region. Sometimes not all of the features are available in all of the other regions, but anyways, that's beside the point right now. So once you select the region, you have the option of launching instances right here, right? Or you can always go to the main dashboard and you can also launch instances from here. So if I go into instances and I launch instance, here is something called an AMI, which I will talk about in a second. But your AMI is basically a copy of your operating system, right? So you get to select what kind of operating system you need, whether it's Linux or a Windows system that you need to run. Amazon kind of provides their own version of Linux. So you have the Amazon Linux 2 version. There used to be a version 1, but now obviously this is the latest one. So you just want to select one of those AMIs. At this moment, we will do this one. And here is where you see all of the instances that you need to select from. Now, before I select this, let me actually show you all of the different instance types. So I go to aws.amazon.com/ec2. You will get to see all of the different instance types here. So I'll just go to instance types. So like I said before, you have your general purpose, you have your compute optimized, you have your memory optimized, etc. Right? And if you look as an example here, if I go to the M5s, if you see here, for example, an instance that is M5.large, it has 2 CPUs and 8 gigs of RAM, right? And this instance supports only EBS, which means it does not have instance store, which means if you select one of these instances, you cannot make use of the instance store that is available on the physical host machine. Only EBS, right? And if you see the network bandwidth, it has up to 10 gigabits per second. And remember, I told you that because EBS is somewhere else on the network, depending on your instance type, there is always a limitation on how much data you can transfer over that EBS connection, right? So for your M5 system, you only have about 4,750 megabits per second. So that's the transfer speed that you will get if you select this one. But as you can see, if you go for larger systems, you can see your transfer speed is much higher for your EBS. And yep, so let's come back here. So you have all of the different instance types over here that you can select from, and it does the same thing. It gives you EBS only, gives a network performance, etc. For now, we'll just select the T2.micro. This is available as part of the free tier options for you. So you can just select that option and you can go next. In this section, there's a lot of additional configuration that you get to choose from for how you run your instances. Right now, we're not concerned about too many of them because there's a lot of networking that comes in over here. For example, you get to select which network that you want to launch your instance into. Right now, we are only worried about the number of instances. And if we want to put in any additional automatic startup instructions, which I will talk about in a second. But most of the other things, you're going to leave it at the default most of the times. But I just want to show you one thing here is if you want to run a spot instance, this is where you select that option. And you can see what is the current market price for the spot instance for a T2.micro. So if you want to get a spot instance for a T2.micro, you can obviously bid for a price lesser than this. You have to bid for a price that's higher than this so that you actually get the instance. But we're not doing a spot instance right now. Okay, we'll just go next. And this is the page where you get to add storage. So here, if you see, this is a root volume. If I want, I can actually add additional volumes. So if you see here, I can add multiple additional volumes, as many as I want. But remember, because this instance type does not support instance store, I cannot, I have no option of adding instance store here. I can only add EBS volumes, right? And if you see here, this shows me the total GB in size and how many IOPS are available. So if I select 100 GB here, how many IOPS am I supposed to get? I'm supposed to get 300 IOPS. You see that it's automatically populating 300 IOPS. So depending on the size of the disk, because it's a GP2, I automatically get IOPS assigned. But if I want X number of IOPS, then obviously I can go for something like an IO1, and I can say I want 5,000 IOPS or 10,000 IOPS, etc. Right? But we're not doing that right now. we're just doing the GP2s. Your GP3s actually also allow you to do the IOPS separately, all right? Because this is a newer version of your SSD, so you get that option of selecting separate IOPS for your volumes. So I'll just select GP2s for now, and I'll leave this to the 8 GB default. Delete on termination. Normally in production, you definitely want to uncheck this, because if you select this and if your instance gets terminated, your EBS volume will also get terminated along with that, right? So you definitely don't want to do that, unless of course you're just testing this and it doesn't matter. But if you uncheck this, you obviously have to also delete your EBS volume separately, unlike it getting deleted with your EC2 instance, all right? Because I'm just doing this as a test, I will leave that checked. Now I just want to go back here, and I want to select a different instance type, an instance type that actually supports your instance store. So if you look at here, these are all EBS only, but you get instance store over here. So these are your C5D instances. Remember, I told you the D mentions that it comes with a disk capacity, which basically means these instances support instance store. So if you see here, these are all SSD volumes. Each one of these instance has a set or a predefined instance store. So you cannot, like your EBS volume, you cannot say you want exactly 10 gigs or you want exactly 100, because whatever is there is what you get, right? So for example, if I were to select the C5D.X large, which comes with 4 CPUs, 8 GB of RAM, and it also comes with one instance store, which is 100 GB in size, which is an SSD. So if I go next here, and again add storage, you can see here the second line, ephemeral, which basically means temporary. So your temporary store or your instance store actually automatically got added here. And if you see, I can't do anything with it. It's already pre-assigned, right? I can't like change how much GB, I can't change the type of the volume, etc. It just comes with the instance, and the pricing is already included as part of the instance. So you don't pay anything extra for this, unlike your EBS volume, which you pay additional depending on how much you're selecting, right? One thing to remember here is, regardless of whether you are selecting an instance that supports instance store or not, your root volume will always be your EBS volume. There are some use cases where you can run an instance with the root volume as your instance store, but remember, that's always temporary, because if you have your operating system on your instance store and if you stop and start the instance, then it's wiped clean. You don't have anything on the disk, so it's never going to boot up, right? So your root volume will always be your EBS volume, because that contains your actual operating system in it, right? So this is what you will get if you select the instance store volumes. Now, obviously, I don't need this, so I'm just going to go back and select t2.micro. And again, I'll just add the default storage, 8 gigs. You get an option to add certain tags over here. So I'll just add a name tag. So I'll just give it a name, and I will say this is, I'll just say this is Session Labs. Okay. And this name tag will get tagged for the instance, for the volumes that is attached to the instance, and also the network interfaces that's attached to the instance. Go next. We will be talking about security groups in more detail later on, but essentially your security groups is kind of like a firewall that protects your instances. So you need to either create a new one or select an existing one, right? I am going to create a new one here, and I'm going to call this session security group. And here I'm going to allow SSH, which basically means it'll allow me to connect to my instance via SSH. You can, of course, add multiple rules here like HTTP, HTTPS, etc. So for now, I'll just add HTTP as well, port 80, and I'm opening it to the entire world. Review, and you get to launch this instance, right? So I'll launch this. Now, before you actually launch an instance, you need a key pair, because how the login mechanism to your EC2s works is based on key pairs. So you don't get to directly log in with a username password on your EC2. Although you can make that happen later on by editing your SSH configuration, by default, you need the key-based mechanism in order to access your EC2 instance. The key-based concept is basically AWS has a copy of your key. You also have a copy of that key. And when you try to log in, you will present that key to the instance. And if it matches, it will allow you to log in, right? So that's basically what the key-based mechanism is. So I'm just going to leave this at the default. So I will choose an existing, no, I'll actually go ahead and create a new key pair so that you can see how you do this, right? So I will do this as session labs. Now, when you create a new key pair, please make sure that you don't forget to download the key pair, because if you forgot it, then you're never going to get that key again, right? So you'll never be able to log into that instance. I mean, there are other ways you can log in, but using the key pair thing, you're never going to be able to log in. So I'll just launch this instance. So make sure you download and keep the key with you. And if you see here, this is just launching an instance. While this is launching, I'd like to stop and ask if you have any questions on what we have discussed so far. Any questions, anyone? What is schedule instance? Okay, Kaveri has a question. What is schedule instance? So schedule instance is basically where you are going to need instances at a particular time of the day. All right. So you ideally wouldn't need to use this, because later on we'll talk about the concept of auto scaling, where depending on your requirement, the number of instances that you need will automatically get created and deleted. But let's say you don't use auto scaling, and let's say at the end of the month you have a certain number of instances that you need. You have a certain number of instances that you need just at the end of the month, so you will create schedule instances where x number of instances get added at a certain amount of time, and after that time they kind of go away. So Alam is asking, can you show me how to restart the service? I will, once this actually starts up. Okay, so we have the instance here. It's in a running state. Now the instance has a public IP and a private IP. Now, one thing I'd like to show you here is that this IP is also temporary. Okay, when you just create an instance, by default, whatever IP gets created is actually temporary, which means if I stop and start this instance, I might get a different IP. All right, but if I restart, I will have the same IP, right? So if I just go actions and go to instance state, and if I say reboot instance, I will keep the same IP. Okay, but what I want to show you is that I'm going to stop this instance and I'm going to start it again, and you will see that the IP will change, right? So this IP right now is 13 dot. Just keep in mind that this ends in 232, right? So instead of a reboot, I'm actually going to stop this instance, and so it's stopping right now. So you see the instance is stopped and you see the public IP is gone, right? Now, if I start the instance back up, I haven't yet got the public IP. Remember, the private IP will never change as long as you don't terminate the instance, which means you're not completely deleting the instance. Your private IP will always remain the same. It won't change, regardless of whether you stop and start. You see, it's a different IP. So I had a 13.IP before and ending with a 232, but now I have a different IP, which is 15.206. So what if you always want a permanent IP, regardless of whether you're stopping and starting your instance? That's when you actually go for something called an elastic IP. All right. An elastic IP is a permanent public IP. So if I say allocate elastic IP address, and I'm saying allocated from Amazon's pool of IP addresses, because there is a way I can get my own IP addresses into AWS, but that's for another day. So if you see, this IP has been allocated to my account. Now I can assign this IP to any resource that needs an IP. So at this moment, this is only assigned to my account. So if I go to actions, and if I go to say associate elastic IP address, and then I get to select the instance that I need to associate it with, and I'll just select its private IP. And if I say associate, now this IP address is associated with my instance. So this is a 3.139, right? So if I go to my instance and if I refresh this, so this was the previously assigned one. If I refresh, you see now I have my elastic IP. Now if I stop and start, nothing matters. I'll still have my elastic IP with me, right? So it will be kind of a permanent IP for the instance. However, when we talk about charges that are associated with your instances, when you stop an instance, you're not charged for the instance that is not running. Okay. However, any resource that was connected to the instance or associated with the instance will continue to be charged. What that means is your EBS volume, which you had assigned before, just because you're stopping your instance does not mean you're deleting your EBS volume. So you will continue to get charged for the EBS volume. Also, your elastic IP, when it's not assigned to your EC2 instance, you will get charged for it. That is only if you have one elastic IP. If you have multiple elastic IPs, it doesn't matter whether it's associated with your instance or not, you will still continue to get charged for it. But if you have one elastic IP, it's actually free as long as it's connected to a running instance. But if it's not connected to a running instance, for example, I stopped this instance, but I still have the elastic IP, then the elastic IP will continue to get charged, right? So I hope that answers the questions about reboots and charges and IPs and all of that. But remember, if I reboot this, even if I did not have an elastic IP, nothing is going to happen. Like I'm not going to lose that particular IP address. All right. Let's try to get onto this instance. So let me copy this IP address here. Now, normally when you create the keys, guys, when you create the key pairs, I would recommend that you actually create the key pair from here before you kind of create your instance. Because if you create the key pair from here, you actually get the option of directly creating something called the PPK key pair. This is used when you want to use an application called Putty or Putty when you want to log into the instance via SSH. But normally when you create it at that last screen where I just created, it actually comes in a PEM format or a PM format. I need to kind of convert that into PPK if I need to use it with my Putty application or my Putty application, however you'd like to call that. Well, I don't want to do that conversion right now. So I'm just going to select this and I'm going to hit connect. So I can actually connect within the browser for my EC2 instance, right? I don't need to kind of use the Putty session. So I'll just say connect over here. And there you go. I am directly logged into my EC2 instance. Now, let me just go back here. I'll take the public IP. As you can see right now, if I put in the public IP, there is nothing there on the EC2. It's not a web server. It's just a plain server with nothing on it, right? So what I'll do is let me try to quickly convert this to web server so that we can see something on the EC2 instance, right? So if I go sudo su, I hope this is visible. Unfortunately, I won't be able to maximize the size on this because it's within the browser. So I apologize if it's too small. But essentially, I'm going to type in some commands over here. So I'm going to first do sudo su, and then I'm going to do yum install httpd. So I did the command yum install httpd. And I'm going to do service httpd start. So this should basically give me a web page for my EC2 instance. There you go. So it literally took me 2 minutes to create a web server. That's what you have over here. You have an EC2 running as a web server with basically a sample web page. Now, of course, I can make this a lot more fancier if I want to, like, maybe pull in a website that I created previously, which I will do in a second over here. Just give me 1 second. I'm just pulling in a website that's kind of pre-made that we can use for this, and I just put that into my system here. All right, so I just got a website template um, as a sample over here, and as you can see, I have just bought that template into my EC2 instance. So this is right now a website that's completely running off of my EC2, and in fact, you can actually check this right now. I'll just quickly post the IP address in the chat. So I've just posted the IP address in the chat. If you can also go and look there, you can see that you can see the same web page, which is basically a sample web page on EC2 instance. Any questions so far, guys? All right. So there are a few more things here which I will cover in a second once we talk about load balancers. Once we talk about load balancers, when we come to do the labs for that, I will go ahead and show you the additional options. Okay. Okay, let's briefly talk about snapshotting or snapshots or backups for your volumes. Snapshots is basically a concept of taking a backup of your existing EBS volume. Okay. Now, once you take a snapshot, you can first of all use that snapshot to recover and recreate that EBS volume that you had before, right? So if there is any issue with your existing volume, you can always just recreate it from the snapshot and then use it. Okay. Now, remember, right now, when I created the website right now, sorry, just a second. So when I created the website right now, I put the template files, right? So I got the template files from somewhere and I put it. Did I actually put it on the instance or did I put it somewhere else? When I downloaded it, it basically got downloaded onto my EBS volume, right? Because the EBS volume is the hard disk, right? So the EBS volume actually has that template files now, right? Which basically means if I want to recreate instances with the same template already in there, I can just create volumes. I can just create volumes from the snapshot of that instance or that volume, and then I can attach all of those new volumes to the instances that I'm creating, right? Because if I do that, then all of the volumes that I create will already have the website that I just put in there, because snapshots are basically backups of my volumes, and because now my website is on my existing volume, any additional volume that I create will also have that website. So instead of just creating additional volumes, I will create something called an AMI or an Amazon machine image. So this AMI is a reference to the snapshot. So the AMI itself does not contain anything. It's basically a reference to the snapshot that you created. If I go ahead and launch this AMI, it'll basically create an instance. Okay, it'll basically create an instance, but it'll also create a volume from that snapshot. Okay, it'll also create a volume from that snapshot, which is basically your EBS volume, right? So it'll also create an EBS volume from that snapshot, and then it'll attach it to that instance for you, right? So this is what happens when you use an AMI, because this AMI is referencing back to a snapshot that someone created. So if I go back to the instance here, and if I go launch an instance, you see all of these AMIs. So these AMIs are basically created by someone beforehand, and they contain all of the operating system and all of the files over here. So when you select this, and then when you go and select your instance, and then when you go next and go to storage, you see you are connecting the root volume, but if you look at it, your root volume is coming from a snapshot, which means that the root volume is coming from an AMI that is associated with a snapshot. And this snapshot has that Linux operating system in it, right? So similarly, you can create AMIs for yourself with whatever application that you want already pre-built into that AMI, so that you don't have to every time create a website or every time put in the software. You can just pre-bundle all of your software into the AMI and then start your instance with that, which I will show you how to do in a second. So when you use an AMI, it creates instances, and then all of those instances that get created, you can basically attach additional volumes that are made from the snapshots. So I talked about EBS multi-attach, same thing what I've said before, but there are certain limitations. You cannot, you have to use a traditional file system, right? You cannot use it for clustering of files, etc., because obviously multiple instances, there are going to be issues. And it's only supported on IO1 and IO2 volumes, and it's kind of limited within certain regions, which is EBS multi-attach is a concept of connecting one EBS volume to multiple instances at the same time. Okay, let's talk about load balancers, and then I will show you some demo on how to make use of load balancers to connect, have multiple instances. And I think that should also answer your question, Alam, where you're talking about deploying application with public DNS, which comes into the picture once you kind of have a load balancer in the picture. I mean, you could do it without that, but I'll just show this to you with the load balancer. Okay, so we'll talk about the different types of load balancers, which is a classic application network load balancer, and a newer one, which is a gateway load balancer. So load balancers are basically service. Remember, it's not a device. It's basically a service that lets you split the traffic between your EC2 instances, right? Now, they're not just used for EC2s, but they're also used for things like ECS, which we will hopefully cover by the end of our session today. But you can also send it to an IP address, etc. Essentially, all of the traffic that is coming into your environment, you're basically going to try to split that traffic across all of your EC2 instance. Now, let me try and probably demo this to you. Like, just give me 1 second. All right. I hope you can see my screen over here, or the board over here. So essentially what you have is you have EC2 instances that you're going to launch within your environments, right? So you have one EC2 over here, and you have another EC2 over here. So normally speaking, when you want to get the traffic into your environments, right now what we did is we had an IP address that was associated with the instance, right? So we had an IP address that was associated with the instance. So right now, when you try to access it, you're basically directly accessing it, right? But what if you have multiple instances that you want to like have the same website on and kind of load balance it, etc.? Guys, just give me 1 quick second. Let me try to align this properly for you. Just 1 second. All right, I think that's better. All right, so you have the IP address that you had, which you were trying to access the website with, right? But essentially, if you have multiple instances, you end up having multiple IP addresses, which is really not what you need. So what you would rather do here is you will actually bring in something called a load balancer. You'll bring in something called a load balancer, where now the load balancer will have an IP address or a DNS. In this case, let's just call it a DNS, right? But it will also have an IP address, right? So essentially what is happening is when someone tries to access your website, all of the traffic kind of gets split between those EC2 instances, right? So you might have the same copy of your website on this instance as well as this instance, and then you will have the load balancer, which is kind of splitting up all of the traffic across those EC2 instances. Now, load balancers do have some additional capability, which means it has the ability to scale dynamically. Remember, this is not a single device. This is a service that is being provided to you. What that means is as more and more traffic starts coming in, it has the ability to scale up or down. So if lesser traffic is coming in, it'll scale down. If more traffic is coming in, it'll scale up. So you don't need to worry about what is the size of your load balancer. Unlike your EC2 instances, you need to kind of make sure that you have the right size of an EC2 so that you can support the load. But with your load balancers, you kind of don't need to worry about that because it'll automatically scale. What it also has the capability to do is it integrates with the auto scaling service for your EC2 instances, right? So if you, for example, add another EC2 instance into the picture over here, you will the load balancer will have the ability to automatically detect that instance and start sending traffic to it, right? So it has the ability to because when you assign the auto scaling group as part of your load balancer, you will have the option where the auto scaling group launches this EC2. It launches this EC2 instance. And once it gets launched, it will inform the load balancer that I have just launched a new instance. So go ahead and send traffic to it. Then obviously load balancer will start sending or splitting the traffic across these EC2 instances as well. Now, apart from this, the EC2, apart from this, the load balancer also has the ability to continuously do health checks to your EC2 instance. What this means is that it will constantly check if the EC2 instance is responding properly. If the EC2 is not responding, or for some reason, it stopped working or whatever, it'll kind of stop sending the traffic to that EC2 instance, right? So if this EC2 instance fails the check, it will stop sending traffic there and only send traffic to the other two instances, so that you always have a working website. So these are some of the functions of the load balancer. We will see this in better action, but essentially you have different types of load balancers that is available, which will kind of send traffic in different patterns, which we will see in a second. All right, so you have your classic load balancer, which essentially sends traffic to your EC2 instances. It doesn't really look at the traffic as to what the traffic is or what it is not. It'll just kind of, whatever traffic comes in, it'll send it to the instances behind it. This is your classic load balancer. And this is kind of deprecated now. You really don't you really don't want to launch a classic load balancer because the newer load balancers have a lot better functions than this, right? So you probably don't want to use this. But when you want to have multiple applications, right? So you have a set of EC2 instances, and you have different applications that you want to run on these EC2s, and you have a different application set that you need to run here. Then obviously you need two load balancers under the classic load balancer scenario, and then you will kind of have that traffic sent separately. For example, over here you have orders.example.com, which is one website, and the other one is images.example.com, which is another website. So you'll want to have multiple load balancers. However, the concept of application load balancer, which is actually the next one after the classic load balancer got released, application load balancer works on layer 7, which means it is able to see what the user is requesting. Remember, I told you the classic load balancer doesn't really care about what traffic it is. Whatever traffic comes to it, it'll just split it and send it across. But with the application load balancer, it has a little bit of intelligence, which means it can kind of see what is the traffic that is being requested. All right, so you can kind of you can kind of see what the user is typing in and then route the traffic accordingly. So in our previous example here, the same thing, orders.example.com and images.example.com, it will look at what the user is typing in and then route it accordingly to your different groups of EC2s. So this way you don't need to have multiple multiple load balancers. You can just have one application load balancer and then just route it accordingly. But always remember, when you bring in things and put in like one instead of two, you are obviously creating a single point of failure. So you also need to consider that when you design your applications. So the application load balancer, like I said, works on layer 7. It has some additional functionality that your classic load balancers generally don't have, which we will look at over here. Internally, within the application load balancer, this is the logic that happens within the application load balancer. Okay, so it's not like two levels or anything. This is the logic that takes place within the application load balancer. So first of all, there is something called listeners. These are basically port numbers, right? So you will have like port 80 here and maybe another port like 8080, right? So for the same port, you can create those rules. And those rules are the ones that I just showed here. For example, the rule for example.com/orders goes somewhere else and example.com/images goes somewhere else, right? So these are the rules that you can create. And you can create that for a single port, or you can have multiple ports that you create, and then each port can have their own rules. Now, unlike your classic load balancer, which can send traffic only to your EC2 instances, the application load balancer, like I mentioned, has additional capabilities. So it can not only send traffic to EC2 instances, it can also send traffic directly to IP addresses, which is reachable from AWS, and also something called ECS or container service, which actually allows you to run containers on AWS. So application load balancer goes beyond just sending traffic to your EC2 instances. Now, when you kind of bunch up a few instances or a few ECS clusters together, and then you put them in a single group, this is known as a target group. All right, this is in relation to your load balancers. This is what is known as a target group. So when you create a target group, essentially you're creating a group of instances that are running the same application, and then you will have another group of instances that are running the same application, and that will be a different target group. For example, this one. So this will be target group 1 and this will be target group 2. This will have one application that is for like orders and another application that's just for the images. Then you have network load balancers. This is, they bought this in because both the classic load balancer and application load balancer had kind of a slight issue when it came to scaling with regards to traffic. So for example, if you had the just 1 second, let me just so essentially, there was this issue with the classic load balancer. For example, okay, I apologize that the line isn't straight here. But essentially, for example, if your traffic that is coming into your environment, right, if it was, kind of gradually rising like this is a traffic that's coming into your environment. So if you had like a classic load balancer, in this case, like I said, the load balancer automatically scales. So this will be like a small load balancer. And as the traffic is increasing, behind the scenes, it will start scaling your load balancer automatically to become like a larger load balancer to support the traffic, right? However, there was an issue where, for example, if the traffic wasn't so linear and you had a scenario where traffic was kind of spiking like that, and if you had a classic load balancer, that load balancer would kind of fail somewhere at this point because of the fact that it cannot scale fast enough in order to support the load that was coming into the environment, right? And in the olden days, what you had to do was you had to basically inform AWS. If you knew the spike was going to come, you had to kind of inform AWS that, there is some traffic that we are expecting. So they used to pre-scale your load balancer to something bigger. They used to pre-scale your load balancer to something bigger so that it actually supports that spike even before the spike happens. Now, this problem does not exist with a network load balancer. The network load balancer can scale almost unlimited, so there is no limitation on how much traffic the load balancer can handle. It can do millions of requests per second, or maybe 1 or 2 requests per second. It's able to scale that much. The only difference here is that this works on layer 4, which means unlike your application load balancer, it cannot see what the user is typing in, because that's happening on layer 7. So it's kind of like your classic load balancer, which means it doesn't see what you're typing in, but it has still some additional functionality. And the fact is that because it's on layer 4, it can work on different ports, right? So it can work on port 80, port 8080, just like your application load balancer, right? It can work on any different ports. You might have like a port 22 or whatever. So it still has the capability to have different ports and send your traffic according to the different ports. But obviously what is missing here, like your application load balancer, are the rules, right? So there's no concept of rules here, because of the simple fact that this is a layer 4 and you cannot really see what the user is typing in. So there's no way you can actually create those rules, or it's pointless because it can't see what the user is typing in. But obviously that scaling issue is no longer there, and you can like scale unlimited without any issues. Kaveri has a question. Can we able to create target groups with combination of IP and EC2s? I believe so, yes. The answer to that should be yes, that you should be able to have different type of resources within your target groups, right? The target group is essentially you're just creating a group of resources, right? But I'll confirm that once we go into the labs and like do that. These are the different functionalities of each of the load balancers. I will probably let you go through this at your own time, because there's a lot of difference in the feature set over here. But if you can see here on the layer 7, the network load balancer is completely missing, and the classic load balancer is also missing. But application load balancer has a lot of functions on layer 7. However, each of them have their own capabilities, so you might want to decide which ones you want to use. How do you get billed when using your load balancers? The billing is based on something called LCUs, or load balancer capacity units. Each one of this is one LCU. So this is for the application load balancer, and this is for the network load balancer. So this is one LCU, this is one LCU, this is one LCU, this is also one LCU. Okay, so each of these are LCUs. Now, how you get billed is you get billed based on the maximum, the biggest LCU you have consumed. For example, let's say your application load balancer is running, and you are having about 100 new connections per second, and you have 3,500 active connections per minute. And let's say you are doing transfer at 4 Mbps, and then let's say you are doing 2,500 evaluations per second, right? So if you look at this, this is basically, if you divide that by 25, this is 4 LCUs, right? And this is 2 LCUs, because 3,000, 3,000, 6,000, so under 6,000, so it's 2 LCUs, and 2.22 and 4 megabits per second, so this is also 2 LCUs, and 1,000 rule evaluations, this is 2,500, so this is 3 LCUs. Okay, so you are basically going to get charged for the biggest LCU, which is 4. So you're basically going to get charged 4 LCUs based on how the consumption works. So don't worry about all these intricate details. Just be aware that you're always going to be charged on the highest LCU that you have consumed, depending on which of those LCUs you consumed maximum. Same thing applies for the load balancer, but it's a little bit different because the load balancer works a little bit differently. But the concept is still the same. You're still going to be charged for the maximum LCU that you have consumed. Any questions so far, guys? All right. All right, let me see if we can. Okay, I do want to mention gateway load balancer here. It's a newer option that is bought in. This is basically the concept of sending your traffic through something called a security VPC or a security instance. Basically, the concept here is that you want to check your traffic before it goes into the instances, right? And gateway load balancers allow you to do that, which means it is allowing you to directly connect to instances that have security software running on them, right? It's basically called virtual appliances. Um, for example, firewalls, etc. You could have them as part of your network, and then you can send the traffic there before it actually reaches your EC2 instances. So that's what gateway load balancers are used for. It's specifically used for that case, not for sending your normal traffic. If you want to specifically send it to a security VPC or a security instance, that's where you will kind of make use of your gateway load balancers. All right, let me try to show you an example of creating an application load balancer and sending traffic to your target groups. Okay, let me. All right, here's what I'm going to do. I'm going to launch two instances, one each for a target group, right? I'm not going to launch more than that. So I will select this instance and I will say t2.micro configure. I'm going to launch two instances. Okay. Okay, I'm going to launch a total of 4 instances. So not 2. I'm going to launch a total of 4. So 2 in one target group and 2 in the other. Okay. And the example that I'm following is basically this example. I'm going to create an application load balancer with 2 target groups, and I'm going to have 2 different applications on it. One is called the orders application, and the other is called the shop application. All right. So I have 2 instances here. Now, instead of having to go in and create the websites manually, I'm going to make use of this thing called Bootstrap. Now, you can use this for your EC2 instances where whatever you put in here is essentially going to automatically run on startup of the EC2. So if you want to quickly get something installed without having to log into the EC2, you can just put that in here. Okay. So let me try to get that script over here. Just give me one quick second. Okay, I launched 2 instances that actually had the shop application, and now I'm going to launch another 2 instances that actually has the orders application, right? So we'll wait for that to come up. In the meantime, I'll just create 2 others with the orders application. So I'll create 2 instances. Okay, they are all coming up. So in the meantime, I will go ahead and create the target groups. When you create a load balancer, it'll actually ask you to create a target group by default. If you already have the target group created, then you don't need to kind of worry about it. So it's better we actually create that beforehand. So let me create the target groups. Okay, so target group type, you cannot mix and match. You have to have the different resources within a particular group. So if you can see here, you have to kind of pre-select what is your target group containing. So I hope, Kaveri, that answers your question around launching different types like IP and EC2s, right? So over here, you have to select an instance. And let me call this the shop application or the shop target group. And it's port 80. Okay, let me just check where my EC2s actually got launched. (9F4). Okay. So these are all some default settings. You really don't need to change much over here when you're launching this, but I'm essentially putting in a target group name. I'm leaving the port to port 80, which is fine because we're not using HTTPS right now. So HTTP is fine. That's fine. Okay, we'll just, yeah. Advanced health check. I am not changing. Okay, I'll actually update the health check over here. I'm putting the healthy threshold to 2, unhealthy threshold to 2, timeout is 5 seconds, and interval is 30 seconds. Okay. Let me try and explain this to you, what this actually means. Just give me one quick second. Okay, so remember I told you that the load balancer has the capability to do health checks to the EC2 instance, right? So it can constantly check the health of the EC2, and depending on how the EC2 is responding, it can either stop sending traffic to it or actually start sending traffic to it, right? Now, there are a couple of things that you need to kind of watch out for, which is when you create the health check, like you need to set some things like healthy threshold, unhealthy threshold, etc. Okay. So there is something called an interval. So for example, this is your load balancer and this is your EC2 instance. Interval basically defines what is the interval between the health checks, right? So for example, if it does one health check, if you say interval is 30 seconds, so it will wait for 30 seconds and then it will do the next health check. Okay. So that's what the interval means. Now, there is the healthy threshold and unhealthy threshold. Unhealthy threshold basically says how many times does it have to fail the health check before it considers the instance unhealthy, right? So, for example, if I say the unhealthy threshold is 2, so it does a health check, waits for 30, and let's say that this health check failed. Okay, let's say that this health check failed, and then it waits for 30 seconds, then it does another health check, and let's say that health check passed. Okay, and it waits for another 30 seconds and it does a health check, and let's say this health check failed. Do you think the instance is failed or not? It's actually not, because this number defines consecutive failures. So we don't have two consecutive failures here, so this is still working. um, but if it does another health check and it fails again, obviously there are two consecutive failures here, so then it will mark the instance as unhealthy, right? Same way, when it does the check, so once the check fails and if it marks it as unhealthy, it doesn't mean it will stop completely. It will still continue to do the health check to check if it comes back as healthy, right? So same concept, interval, okay, and healthy threshold. So if you say 2 for the healthy threshold, it means that if it actually passes 2 health checks, it will consider the instance to be healthy. All right, let's switch back. All right, so let me put the healthy threshold as 2, unhealthy threshold as 2, timeout is 5 seconds. Timeout is basically how much, when it does the health check, how long do you wait before you consider that health check as a failure, right? So when we actually do the health check over here, once it actually sends that health check request, how many seconds does it wait before it considers that health check as failed or pass is basically the threshold, right? So you have the threshold here as 5 seconds and the interval as 30. Success code 200 is basically saying whether it's a, what is the code that the server is returning. I'm just going to leave it at 200, which is fine. Okay, you can't have underscores here. I'll put in a hyphen. I'll go next. And here I will select my shop applications because I'm creating the shop target group. And remember, once you just select them, that's not it. You actually have to add them. And once you add them, you can just create the target group. Similarly, I'll create the other target group, which is the orders target group. Again, port 80, same VPC, HTTP, all of that's fine. And this I'll change it to 2. And this time I will select my orders application. I will include them and I'll create the target group. Okay, so I've created the target groups. Let me just name my systems as well. Okay, so I've created the target groups. Now I'll go ahead and create my load balancer, which is over here. Oh, sorry, you're not seeing my screen. Sorry. Okay, so what I did basically was I created the target group. I selected instance. I gave it a target group name. I selected the protocols. I changed this healthy threshold to 2. I did 2, 5, 30, 200, and I just went next. And here I actually just selected the instances and I just included them. And once I did that, I just created the target group. All right, that's all I did. So for the shop target group, I selected the shop instances, and for the orders, I selected the orders. So may cancel out of that. So you have the 2 target groups here. And I just renamed my instances. So we're ready to go ahead and create the load balancer. So I will do that. I will go to load balancers. I'll create a load balancer. Okay, so you can see classic load balancer. It says that it's a previous generation, so you really don't want to do that. But then you have your application load balancer here. So let's create that. And let's call this sessions demo. It's internet facing. You can create an internal load balancer as well if you're just using it to balance your applications internally within your organization. But obviously, we are creating an internet facing one. So we're just using IPv4. We're not using IPv6. Now, let me just quickly check. So if you see my instances, the shop instances are in 1A availability zone, and my orders instances are in 1B availability zone. So they are in different availability zones, right? So I need to select both my availability zones here. I'll just make sure that the subnet is also correct, which is under networking. Subnet is 480, and this is CB4 and CB4. Okay, so 480 and CB4. Okay, so I selected the subnets, and I'll just create a new security group for the load balancer. And I'm just adding HTTP traffic because I'm only opening port 80, so I don't need anything else. So I'm just allowing HTTP traffic in there. All right. So I'll select my security group for my load balancer. Again, I'm doing only HTTP port 80. And here is where you need to kind of select a default action. So for now, I'm just going to select the shop TG as a default, but I'll just show you how you can create these rules in a second. But I'm just selecting this as any one by right now because it needs at least one target group in order to get created. So I'll just add that for now. I'll show you how to later modify that. There's something called global accelerator, which we'll later discuss in the networking section when we do the session for networking. So I'll just create this load balancer. Okay, so my load balancer is created. Now, if you go to listeners here, you can see that there is one listener here. Now, if I refer back to my diagram here, We have created listeners, but we have only created one listener, which is the port 80 listener. Now I need to create these two rules in order to send the traffic to um, my orders and my shop website. Okay, so there is the listener already created. So I will go into view edit rules. Now by default it always needs like a default target group. So if you don't type in exactly what the first target group needs and the second target group needs, where do you send it? That's the question. So that's the default. So I'm just going to select one of the target groups as a default. That's fine. I'm just going to leave it there. I'm not going to modify that. What I'm going to do is I'm going to add a rule here, and I'm going to insert a rule, and I'm going to say if the condition or if the path, right? So if the path matches slash shop star. Okay, so anything after star, and then I want you to forward that to the shop target group. Okay, and I want you to send all of the traffic to the shop target group, and I will select that, and I will save that. Again, I will create one more rule, and that will be if the path is slash orders star, I want you to forward that to my orders target group. So there is always a default rule that currently goes to the shop target group. That's fine. But I have here that anything slash shop should be sent to the shop target group, and anything slash orders should be sent to the orders target group, right? So I have created those rules. Now I just need to go to monitoring. Okay, I'll go to my target groups and see if the instances are online. Okay, because remember, these instances still need to pass the health check. As soon as they get added into the target group, it doesn't mean they'll directly start working. They need to also pass the health check, right? So let me see targets. Yep, they are healthy, right? So okay, so they should both work, which means now if I open my okay, I hope you were able to see my screen. So now if I go to my load balancer, this load balancer has a DNS name, right? This is the URL for the load balancer, right? I can just take this and I can put it over here. And if I say slash shop, there you go. There is my shop application. And if I say slash orders, and there is my orders application, right? So you see I have just to look back here, I actually have two instances, right, in each of the target groups. So shop 1 and shop 2, and orders 1 and orders 2. So if you look at this, look at the IP address. Okay, that's 172.314.39. This is the private IP address of the instance. I'm still on orders, and I'm going to refresh this, see if this IP actually changes. This is to see if it's actually load balancing within the target group. Okay, so just to explain this, when you have this setup, now it is sending traffic according to the URL, but it's also load balancing within that target group. Like if there are multiple requests that are coming in for orders, it will basically balance it between this and this instance, right? So these two instances. So if there are multiple requests coming in for orders, it will balance it between this and this. So yeah, so it does load balancing internally within the group. And if there are multiple requests coming in for shop, it will balance it between this and this EC2. So let's see if that's working. Let me refresh this. So this is 4.39. And there you go, 12.185. So you can see it is also balancing it between both those two EC2 instances. And again, I'll do the same thing on the shop. This is 35.26. And if I refresh this, there you go, 39.176. So it is actually balancing in between those EC2 instances. And again, these are the actual IP address of the EC2s. If I look at this, 35.26, 39.176, 39.176, right? Any questions so far, guys? Alamas, please explain cross-zone load balancing. So cross-zone load balancing is pretty much exactly what you saw right now, because you have EC2 instances that are available across two different availability zones. If you saw that, my EC2 instances are in 1A as well as in 1B, right? This is kind of default given by your load balancers. So in your classic load balancer, you kind of had to enable it, but this is kind of your default option that you get with your load balancers. If you do not select, like remember when I created the load balancer, I had to select which are the AZs that I'm using. So if I selected only one AZ, it was essentially not going to do cross zone load balancing. All right, any questions quickly? We are almost out of time. All right. I hope these parts are clear to you. Let me quickly cover the remaining topics here, which is basically ECS and EKS. So I'll just give you an overview of this because you kind of need to have a little bit understanding on container technologies to kind of use this. So unfortunately, we will not be doing a demo right now because we are almost out of time as well. But let me quickly explain these concepts to you. So let's talk about monolith versus microservices and VMs versus containers, as well as the AWS container services. So when you look at host-based technology, initially it started with the concept of mainframes, which still exists, which is one single large system which processes everything, right? Then we came into the concept of client host, where you have a server and you have a client, right? So you have the host and you have the client. So the host will do all of the main processing and the client will be accessing the host using their client machine. Then came virtualization. Obviously, all of these. Okay, I think there's one question here about, is there any other way to access public DNS? Okay, let me just, probably before I go forward with this, I just want to quickly show that you can actually use your own domain names with your load balancers, guys. So this will actually require Route 53, which I will go into detail probably in another session when we have the networking session going on. But basically in this, you have to have a domain name. So for example, in this case, I have a domain name called aws-training.in. I can create a record, and let me say that this is session.aws-training.in. Okay, you can just have it this, or you can have www, but I've already used that, so I can't use the same thing again. But essentially, I will do an alias, and I will say I'm sending this to an application load balancer, and I will select my region, and then I'll just select the load balancer, right? And if I create this, can see it's created the record, which is here. And if you open this up now, and then if you go to /shop, sure enough, you have your website there. And if you go to /orders, you have your website there as well. So I hope that's clear. If you can use a public DNS, if you want to use your own domain name, you can kind of link that as well. Okay, let's come back to this. So virtualization is where you have the concept of hypervisors, and this is where EC2 itself comes in, right? So this is where you have your virtual machines, your EC2s, which run on physical hardware, but is virtualized, so you get better isolation and more use of your actual physical machine. But the average lifespan for this is maybe like a few months, right? But then you have microservices. These are decoupled environments where, instead of putting everything on a single server, you have different bits and pieces that are working on different areas. So as an example, if I were to go to the Amazon site, if you talk about microservices, for example, you can see that this particular section is a single, or let me actually open up a product. Maybe if I can just show you one product. So this section, like the images section, is like one microservice. And if you see this section where it shows you the pricing and all of the information, that is like one microservice. And all of this information which pulls up details about, like this section might be another microservice, but all of that is combining together to like give you the full service, right? So that's the concept of microservices. You're basically breaking up the application into smaller pieces so that you can actually do maintenance on that small piece rather than taking down everything and redoing everything. And you can also do faster upgrades because you're not having to upgrade everything, you're just doing that one small part. This is where you will see a lot of use of things like container services, etc., where everything is running in small containers, and that's essentially what we will be talking about. But I just want to finally mention this: there is the serverless part as well, where you're no longer using physical machines, you're no longer using VMs, you're no longer using containers, but you're essentially using a service that you are not using a server for. Of course, there are servers in the backend, but the service that you're using, you're not connecting to a server, you're not running anything on a server. You're just saying, here is my code, run it for me, right? But what we are looking at today is just the microservices part. Tomorrow, we will have the serverless session. So under microservices, like I said, the concept is that you are kind of going to break up your application into multiple smaller segments so that you can do rapid development of your applications. You can make changes without having to wait for everyone. This is the monolith, which means if you are having to make any changes to your web front end, it's going to affect everything else. This is basically what your monolith is, right? Because everything is very tightly integrated. Unlike where you have your microservices where everything is basically decoupled and they all talk to each other using APIs or something like that, right? So you can like upgrade your web front end without interrupting anything else within your application. So think of it like this: each one of this is a individual service which will run inside an individual server, so to speak, right? But instead of servers here, you have the concept of containers. So on the container side, AWS has three services: Amazon ECS, which is the Elastic Container Service. Then you have Amazon EKS, which is the Kubernetes service. And then you have AWS Fargate, which is also a container service, but it kind of falls under serverless. So tomorrow, I believe the Lambda functions as well as Fargate will be covered. But today, let's just talk briefly about ECS and EKS. VMs versus containers, virtual machines or virtual servers versus containers. So before, if you remember, we talked about your host hardware, on top of which you're going to run your hypervisor. And on top of that, you will have your virtual machines. Now, within your virtual machines, you will obviously have your guest operating system, you will have libraries, you will have dependencies, and then within that, you will run your application. The problem here is that every time you need to run like a different application, you have to maintain the operating system, you have to have the dependencies, you have to have the libraries in every single virtual machine. And this is basically an EC2, so you have a lot of maintenance to kind of do just for running that application, because you have to update and patch your operating system. You have to make sure all of your dependencies and libraries are up to date. For example, the recent log4j vulnerability with Java, you have to literally update that on all of your systems, right, if you have virtual machines. So while this is very useful, but when you talk about microservices, you're unnecessarily wasting a lot of resources of the host hardware by running multiple operating systems on the same host hardware, right? That's where containers come in. So what containers do is you have your host hardware, and then you have your host operating system, which you will kind of need in order to run something like a container service. Now, there are so many different container services, but obviously the most common or frequently used one is known as Docker. Now, what you do here is you're essentially running the containers on top of the Docker service, right? And this will only have the libraries and dependencies and then your application. So you can see here a big chunk of that guest operating system is removed, so you don't have to worry about having to maintain your operating systems here. And everything your application needs will be contained within this container. And because it doesn't have any operating system dependencies, well, mostly, you can take this container and literally run it on any system that has Docker. Okay. The problem here is that if you need to run this application, you need to make sure that that application and that guest operating system, everything matches. And if you try to run it on a different if you try to run it on a different virtual machine, it might not work. But with containers, that's not an issue. You basically can just take that container and run it everywhere as long as you have the container service like Docker available. So that's just a quick preview of VMs versus containers. Um, Now, where are you going to run these containers? You're not going to pay for a heavy, like a high priced bare metal server from AWS, right? You're going to run those containers on your EC2 machines, right? But your EC2 is already a virtual machine. So how are you going to run a container inside your virtual machine? That's where the concept of containers inside VMs comes in. So here you have the host hardware, you have the hypervisor in order to manage your EC2 instances. Then you have your EC2 instances. Within your EC2 instances, obviously it will need the guest operating systems. But within your EC2s, you will install Docker, and then you will have containers running within that. And all of your libraries and dependencies and everything will be contained within those containers. So on your virtual machine, you're only worried about guest operating system and Docker. There is no additional dependencies that you have to kind of run on the virtual machine, because everything that the container needs is already within that container. Everything the application needs is within the container, right? Okay, how do you run containers? Well, there is something called a concept of container image. So this image might be anything. It might be a web application, it might be some other application that you run. So essentially the idea here is that, for example, with Docker, you run like the Docker run command, and you specify how many instances of that application you need. So this will be running on your EC2 machines. So you say that you want 2 copies of your application running, you will run the Docker run command, and you will create X number of containers that you need. And where do you store these images? You store them in something called the container repository, right? So you have these images which are running as containers, but obviously you need to store that somewhere. So that's where you will store it, in the container registry or repository. So for example, over here you have Apache, you have MySQL, and you have PHP. Each one of these are container images, right? So you need to basically pull them in order to run them, right? So here you saw we did the run command, which in turn created the instance. But obviously you don't, if you need to run it, you obviously need to first go ahead and pull it to your system, and then you do the run command. Same thing with any of the, let me show that to you again. You run a pull and it will run the container. Again, you run a pull and run, then it will run that container as well. So this is where we come to EC2 container service, or ECS. So you can do all of this that I just described yourself, like launching, like running Docker on your EC2 instance and then pulling the image and doing a Docker run. You can do this yourself. The only problem is, once you start doing a lot of this, for example, when you start having hundreds of containers that you need to run, it gets very difficult to manage all of this manually by running these commands. Of course, you can do a little bit of automation, but then it gets really hectic if you don't have a container management system, right? If you have a container management system, you can tell that system how to run your containers and how many to run, where to run, etc. You can mention that in your container management system, and then that will do it automatically for you. So instead of you having to manually pull, run all of this, you already predefine this, and then the management system will take care of it. So this is where you have your EC2 container service. So EC2 container service is nothing but a managed container service. So it'll kind of do all of that part where it will automatically deploy your containers to the existing EC2 instances. So you don't have to like do the run command every time. You just say that here is my container, and I need these many copies of my container. So if you say this is my application in this container, you give the container to the ECS service, which is EC2 container service, and you tell I need 3 copies of that service. It'll just do that, right? So it will automatically maintain those 3 copies of your application. If one of the copies fail, it will automatically bring up another copy. So it's kind of managing everything for you. So it's basically a container management service. Okay, it integrates with ELB, like I mentioned before. You can have your application load balancer sending traffic to your ECS. Now, I'm going to show you something here. It might look a little bit confusing here, but don't worry. I'm just showing you the theory part of it. You just need to get the overall understanding of this. You're not going to be asked 2 specific questions on this with the exam. you need to have an overall understanding of this. So within your ECS service, you first kind of have to like go into your ECS, and within your ECS service, you have to create ECS clusters. ECS clusters are nothing but EC2 instances. So if you create 5 EC2 instances and put them in a cluster, it's basically an ECS cluster, which you're basically telling ECS is that this is the number of servers that I need you to run my application on. Okay, so you're just creating a cluster and you're telling ECS to launch your containers into those EC2 instances that belong inside this cluster. So obviously you will have EC2 instances as part of that cluster. Now, when you launch it as part of ECS into a cluster, it will automatically have Docker and the ECS agent already part of it, right? So if you launch instances as part of an ECS cluster, it'll already have the Docker agent on it, plus the ECS agent in order to make sure ECS works properly, that ECS can actually do the run command for you without you having to do it. And then you create a task definition. This is where you're going to define how many copies of your application do you need, where do you run it, etc. So the task is basically, like I said, how many times do you need to run that application, and how many containers are part of that task, etc., that you define within the task. And then you just kind of launch the task, so to speak, and ECS will automatically run that for you across all of the EC2 instances within the cluster. Now, obviously, you want to make sure that your application is up and running. So you will have something called a service which looks at that application, right? So if any one of these containers happen to fail at any point of time, right? So if these tasks fail, as part of the service, ECS will automatically understand that task has failed because it's monitoring it as part of the service, and will automatically launch a new task in its place in order to make sure that your application is actually working. Okay, so just these points here you need to remember, which is ECS cluster, which are your EC2 instances as part of the service. And then you have your task definition, where you're going to define what are the containers that you need to launch and how many copies of it do you need, which will be launched as a service so that ECS can kind of monitor it and ensure that it is up and running all the time. Now, when AWS came out with ECS or EC2 container service, that time containers were still kind of, not yet that famous in the corporate environment. And they were trying to essentially replace Kubernetes, but then obviously Kubernetes got caught up more faster and people adopted Kubernetes much more faster. Kubernetes is also a container management platform. All right. So it does the same thing. A container, the exact word that you should be actually using is container orchestration platform, whether it is ECS or Kubernetes. It's basically a container orchestration platform. It automatically does most of those things that you would have otherwise to manually do, right? So in the fight between ECS and Kubernetes kind of won, and now AWS also contributes to Kubernetes itself. So there is already a tight partnership there. You can choose to run your containers either on ECS or Kubernetes. Now, if you do decide to go with Kubernetes, you have a choice. You can run Kubernetes on your own EC2s, which means you install the Kubernetes service, you manage the platform yourself. There is still a lot of manual work to do. Or you can let the Elastic Kubernetes service do it for you, right? So essentially that's what it is. You're just letting the Elastic Kubernetes service do all of that thing that you would otherwise have to manually do in terms of setting up the Kubernetes service and managing your containers on it. They are basically giving you an environment where Kubernetes is already set up and you just need to start using it. And like I said, you need to have knowledge on Kubernetes before you can actually use this service. They do stay up to date with all of the latest Kubernetes updates as well. So you don't need to kind of worry whether it's going back a little bit or not. And I think with that, we have come to the end of today's session. Let me quickly try to preview what we have covered in the last 2.5 hours, which I know is a lot. So we started off with EC2 instances. We talked about what virtual machines are and how the hypervisor allows you to create virtual machines. And we discussed how EC2s are basically the virtual machines on AWS. We looked at the different instance families for the EC2 instances. We talked about the additional features like elastic GPUs. We talked about how you differentiate between the instance types. We discussed the three billing models: on demand, reserved, and spot. On demand is where you just pay for when you use the service, and reserved instances where you kind of have to pre-assign a contract, where you're getting a contract for a certain amount of time, where you pay a certain discounted price. Spot instance is marketplace based pricing. You bid for the price, and then if your price is higher than the market price, you get the instance. If it goes below that, you lose the instance. Then we talked about savings plans as well as capacity reservation, tenancy models: shared host instance, dedicated host, and dedicated instance. We talked about the Nitro hypervisor and AWS outposts. We talked about EBS volumes, how the EBS service works, and how you attach and detach EC2 instances, EBS volumes to the EC2 instances. We talked about ephemeral disk or instance stores. We talked about the different types of volumes and how they matter in terms of performance, whether it is IOPS or throughput that matters to you. We talked about snapshots and how you can create AMIs. We talked about load balancers, all of the different types of load balancers: classic, application, and network load balancer. And we also did a demo on setting up your classic load balancer. And then we talked about the concept of microservices and essentially what containers are, what Docker containers are. And we also talked about ECS as well as EKS. All right, everyone. I think with that, we have come to the end of today's session. I know it's been quite a lot, but compute services is quite a large, a service within AWS. There are a lot more. There are a few more things that we could have probably touched on, but we've kind of run out of time. So if you do have any questions, please feel free to reach out to us on the Discord group. So I hope all of you have joined the Discord channel. If not, please let us know. We'll try to get you added into the Discord group, and you can ask any questions that you have there. I hope to see all of you tomorrow as well for the serverless sessions at 2:30. I believe we'll have another speaker, but please do join in so that we can do the next session as part of the bootcamp. Once again, I'd like to thank you all for joining in. And I think we don't have any other questions. Just a quick minute. If you have any questions, please do post on the chat very quickly before we wrap up. All right, looks like no questions. Thank you everyone for joining, and see you tomorrow at 2:30. Have a good day.